Welcome, everybody. Thank you very much for joining us this evening. My name is Daniel Carey. I'm director of the Moore Institute. Delighted to be hosting in conjunction with CALM, the Center for Applied Linguistics and Multilingualism, this seminar this evening as part of a series. And we're going to be hearing from John McCrae shortly about in his talk on artificial intelligence approaches to multilinguality. But before that, I just wanted to offer some very exciting news in case you hadn't heard, but our colleague in Italian, Anne O'Connor, has been awarded a European Research Council Consolidator grant, which was just announced yesterday. This is a wonderful achievement. We send congratulations to Anne. She's a member of CALM and a great colleague. It's a very exciting project called Pietra on the communication and translation practices of the Catholic Church. It engages in interesting ways, I think, with the kinds of things that John is also interested in terms of big data and of translation practices and of various different platforms and multimedia platforms and social media platforms of Facebook and Twitter, for example. So I'm very excited about this news and really looking forward to seeing the results of that project. I'd now like to hand over to Laura McLaughlin, who is the co-director of CALM. So Laura, over to you.
Thank you very much, Don, and good evening and welcome everybody. So we are delighted to introduce this, which is the second webinar of our series of 5 for the current academic year. And you can find details of the remaining events on our website, which is nuigalway.ie/calm, and then go into news and events. So for tonight, it is my pleasure to introduce tonight's speaker, who is Dr. John McCrae. John is the leader of the Unit for Linguistic Data at the Data Science Institute of this university. His work has focused on the intersection of natural language processing and data science, and he has been a key figure in many national and international projects. And we'll name just a few. For example, he led the development of the Linguistic-linked Open Data Cloud, a large-scale integration of many language resources. He's the coordinator of the Pret-a-Lord project, funded by the European Union H2020 program. And this is a project which aims to make linguistic-linked open data ready to use. He is also a work package leader in the Alexis projects on building a new lexicographic infrastructure for Europe. And he is funded by the Irish Research Council under the Laureate program with the Cardamom project, which is focused on the development of the comparable deep models for minority and historical languages. So tonight, John is focusing on artificial intelligence approaches to multilinguality. He will give us an overview of artificial intelligence applications, including machine translation, and will focus particularly on the application of artificial intelligence to minority languages and historical languages, and historical linguistics. He will also cover work on the development of computer-assisted language learning systems. So over to John. And I'm really looking forward to your talk tonight, which adds a new perspective to our webinar series on applied linguistics and multilingualism. So John.
Okay, thank you so much, Laura, for the introduction, and thank you so much for the invitation. I'm very happy to come and talk to you all. So I'm talking today a bit about artificial intelligence. So obviously I'm a computer scientist by training, and we work at the Data Science Institute, which is this institute that's way up in the north of the campus in the Dangan Business Park. But we're very interested in how we can do this sort of interdisciplinary research and apply computing techniques to challenges in languages and in language learning. So I'll start a bit by talking about, perhaps the revolution that's going on in our field at the moment. And I think, even many people who aren't very aware of what's going on in computer science and AI have heard this term deep learning. So deep learning is these models, like this diagram shows, where the computers make many internal representations of the data and sort of learn about the data themselves. And this is something that has really kind of revolutionized the way that we're doing our research and the applications we can build. So, in many fields, a kind of revolution like this might be caused by, some new techniques, some great scientific breakthrough. But in actual fact, this deep learning stuff, it was well understood even in the 80s and 90s. So what's actually causing this change in computer science is two things. First of all, just a huge amount of data we have. So we're working with really big data sets, and I'll talk more about the size of some of the data sets that we work with. But the other thing that's also enabling, of course, is just massive computational power. We use these big servers with custom GPUs and CPUs to compute, and we can solve these problems, and our AI is learning much better just because of this huge amount of computational power that we have nowadays. So this is sort of the slide, I think, which is perhaps the most technical, and I'm going to try and teach you something. So the question of how do we teach an AI, and there are many ways to go about teaching an AI, but the one that is the majority, and probably 90% of AI approaches are based on something which is called the supervised method. So the supervised method, what we do is we show the computer lots of examples, and we tell it what we think it should output. So in this diagram on the right, we give it lots of maybe pictures or other descriptions of objects, and we tell them they're either apples or cupcakes. So we've shown this AI lots of apples and lots of cupcakes, and eventually, after we show it a huge number of these and train it for a very long time, we get a system where we can take an image, now without telling it whether it's an apple or cupcake, and it can tell us, it can predict whether this is an apple or cupcake. So this works, but there's obviously some drawbacks to the supervised method. So one of the things is, of course, that if we show it something else like an orange, then it can only answer two things. It can only answer apple or cupcake, and it will quite happily answer either apple or cupcake if we show it an orange. Another big issue is that if the data changes, if people start baking a different kind of cupcake, then the training is useless, and we might not be very accurate at dealing with any change. And finally, and something that I think is very important to understand, is that there is always a certain kind of, it can only deal with the training data we have. And this is something that we see a lot coming up with the AI methods as they're applied. And we have examples like facial recognition software that works less well for people of African heritage, because we haven't shown as many people, we haven't got as many examples that we've shown to our AI of people with African heritage. So it doesn't work as well. There's similar examples where, we have bias coming in because of this. So there are some limits to the supervised method, but it's still sort of the main one. I'll come back to this idea a few times in the talk of how we use this supervised model to kind of get results. So of course, one thing that many people might think about deep learning is that it's all hype. Now, I will say no, I don't think it's all hype. Deep learning, we see from our work, it's something that's really making big improvements and really enabling new things. But, there are also many in our field who make claims that are perhaps a little unrealistic. So the text in the right, the top bold words I wrote, but all the rest of the words were actually written by an AI. So I wrote up to include, and then the AI wrote the rest. And this model was written by a system that's called GPT-2. And when GPT-2 was first released, they said that they wouldn't let general members of the public use it because it was so powerful that it might, allow people to make extra effective spam, or to do kind of various nefarious things with this kind of technology. Now, I think that was a bit over the top. You see, if we look at what this AI wrote, in many ways, it's great. I mean, it's comprehensible. It's all English. There's not any obvious grammatical mistakes. But if we look at a little bit deeper at what this AI wrote, we'll notice some obvious problems. It talks about artificial intelligence approaches, including artificial intelligence, which is a little bit, not very helpful. Wouldn't get good marks if it was a student who wrote this. But when it goes on to the second paragraph, we quickly see that it's kind of lost the plot a bit. It's talking about things, but it's talking about human brains, and it introduces someone called Scott. I don't know where Scott came from. That's what the AI kind of dreamed of. So it's quickly kind of losing the point. So, the idea that AI is going to completely replace, newspaper writers or something, I think is still very far-fetched. But, in terms of what this can generate, this is, a pretty impressive kind of technique compared to what we had even 5 years ago in AI. So obviously the big technology when we talk about multilinguality and artificial intelligence is machine translation. So I found this picture on the right. It was on a talk given recently by a colleague, Kevin Scannell. And this is a case where someone has obviously used machine translation. Now, in some ways, this is actually quite a good translation. I don't think it's, or in some ways it's good in the sense of the progress of machine translation, in that these are all Irish words that it's used here, and they're organized in a way that's grammatical. It doesn't look necessarily wrong, but of course, as any Irish speaker has probably already realized, the system has made a big error here in that it's misunderstood the word leads here as lead, the metal. So the meaning of the Irish sentence here is something like keep dogs on lead, which is very puzzling. So, this is kind of where our machine translation, it's very useful, but it has limitations at the moment. So we go about doing machine translation. And again, this is an example of the supervised method. What we do is we collect known translations. So we'd collect, say, in this case, English text, and we'd have our target language text like French, and we just give it lots of examples of English, and it produces the French output, and we keep training it until it produces French output that is close to what we have in our data. And for a language like French, we can do this very well because we have such an enormous amount of data. This open source corpus, which is probably much smaller, by the way, than something like what Google has. But this open corpus has 7 billion words of text. So that's 7 billion words of English, 7 billion of French. If you think about that, that's probably more than every written book in the Hardeman Library. It's just a huge, truly enormous amount of text. And for language like German, we have a similar amount. And when we look at even at Irish, we actually have quite a lot. I mean, 80 million words is still an enormous amount of text. Now, of course, Irish is quite disadvantaged, and even compared to here, I've picked Latvian as a typical small European language. And, we still only have about a third of the amount of text we have for, this typical small European language. But in other ways, Irish actually isn't so bad off. If we look at Bengali, which is the 6th most spoken language in the world, over 200 million people speak Bengali. We actually have more parallel text now for Irish than we do for Bengali, or similar for other large languages like Tamil. But there are other languages like Gaelic, I mean Scottish Gaelic here, of course, where we have very, very little data. In fact, we have less than 1 million words for Gaelic, and it's actually very hard for us to take our standard approaches and train a system for a language like Gaelic. So how do we go about translating? So I'll show you a little example of how we do it. So we'll have our foreign text. Here we have our Japanese sentence. And we kind of do this in 3 steps. So first of all, we try to group the words together into units that make sense, because we know that the bigger unit we can translate, the more likely we are to be correct. The second step is we then go and reorder. So Japanese in this example is a verb last language. So this last word, suraru, is actually the verb. So if we're translating into English, we try and reorder to move that into the position where we'd expect it to be in English. And then we translate, and we get an English translation by translating each of these blocks independently. So this is a method that, it's not quite the state of the art anymore, but it gives you a little bit of an idea about how we go about translating. And what we've done is we've taken this kind of block model, block and translating, and we actually created quite a fun little app out of it. So the goal of this app was to try to teach Irish well, we were aiming it at primary school students, so who are learning Irish, not obviously from Irish speaking families or bilingual, so monolingual English families when their children are learning Irish in school. And so we took a children's book here, Small Bird's Big Adventure, and we started translating it. We translated it into Irish, and then we used our system to analyze this. And what we did was we tried to create this idea of learning by reading. As we're learning by reading, we'd introduce Irish language words in place of where we'd have the English words. So for example, we'd translate small bird, and our translators came up with this wonderful Irish word "éinean" as a translation small bird for the name here. And we'd follow this up, and we'd as the reader is progressing, they'd get more words introduced to them that are in the target language. And of course, this is an interactive app, so they could click and they could see you know, if they didn't know what this, say, Irish target language word was, they could see the translation. So we kind of went with this, and, you know, we'd actually had some very big plans to try to actually, you know, do this with some schools in the local area in about March. So yeah, as you can guess, the pandemic kind of killed those ideas. We're still hoping at some point to go back into this, but you know, I think this is something that was interesting, and, you know, about how we can do some teaching. We did, however, come into some very obvious problems, and, you know, I think, again, some of the Irish speakers might already be seeing some of the issues we have here. So, for example, one thing we had was words that would have, say, some kind of grammatical or morphological change in target language. So, for example, here, the word bhach has a BH prefixing it, which is normal in Irish, but might seem odd, you know, for someone coming from an English context and seeing this word by themselves. There was certainly a sense that it might be more natural to, you know, have the more dictionary form here. But the other bigger problem we had was to do with word order. So as you can read here, you know, the word order, say, in this top sentence of lived Aineen in house beautiful. I mean, that is the correct word order in Irish, but it sounds very odd in English. So the degree to which, you know, we would be able to use the target language word order, and when we should use the source language word order, and how we should mix those together was something that I think remained a bit of a challenge, and something that we hope and still hope with actually involving real learners, that we could kind of find some answers. And I'm also very happy if someone has any comments in the questions about, you know, or comments at the end about how they think, you know, would be easier for learners to kind of adopt this. So talking about, you know, computers and big data and language learning, there's sort of an elephant in the room, or perhaps an owl in the room. So there's apps like Duolingo being the most famous, that are actually, you know, are very widely used now. And certainly, I think for those of us who are teaching foreign languages in the classroom, you'll have seen a kind of change here. I've chosen a slightly funny picture of the Duolingo owl, because there's all of these internet jokes about the owl coming to kill you if you don't do your Spanish homework. But Duolingo is they're actually a really great company who are engaging with researchers, and they make a lot of data available. And there's all of this big data that they're collecting about learning, about how people learn languages. You know, and we can go and we can actually use this in our big data, and we can even predict, you know, which words are people likely to learn easily, which words are they going to find harder to learn. And this is something that we're actually now exploring in the context of a research project that a student of mine is doing, which is really about modeling language acquisition and modeling language learners. And we sort of have an idea that this is something that could, you know, not replace a teacher, but in fact help a teacher. So, you know, our teacher will come along and, you know, will be able to submit their lesson plan to a robot, an AI. And then the AI can actually take this, and it can analyze all of the data it has about these users. And of course, you know, there's lots of data, you know, every single exercise that we mark, you know, creates more data. And obviously, and again, because of the pandemic, we've suddenly all moved to doing a lot more stuff online. So there's a really big potential for us to create a lot of, you know, very specific data about people, about our learners, about our students, and really get very specific ideas about what they know and what they don't know. And here's where, you know, an AI can really do something that, you know, a human teacher couldn't, because, you know, humans are smart in many ways, but, you know, we won't be able to remember a student's performance on every single word in their vocabulary, and we wouldn't know, for example, which particular vocabulary gaps a student might have. So this is something that, you know, that an AI can do, and because of the big data, we can actually, you know, make these predictions, and we kind of hope that we're moving towards applications that can really, you know, improve how people are learning languages. So another aspect is very important, of course, and particularly, you know, us being situated here and near to the Irish-speaking areas is AI for minority languages. So I talked a bit earlier about how little data we have for Gaelic, but one thing that I think many people are aware of is that Irish and Gaelic are very similar languages. Even for many people say that they're mutually intelligible, that one speaker one can understand another. Certainly I can say something much weaker than that, but Irish speakers can learn Gaelic much faster than non-Irish speakers. The languages are so similar, the grammar has so much in common, but Irish speakers will learn Gaelic so much faster. So we had a thought, well, if this applies to humans, does it apply to AI? That is, if we teach our AI Irish first, where remember we have 10 times as much data, 100 times as much data as we have for Gaelic, will our AI do better in Gaelic if we first teach it Irish? So this is exactly what we do, and we take our AI and we start by giving it examples of Irish text, which it's translating here into English as our target language. And this is as I said, it's a supervised method. We take our text and we give it the known English answer, and we keep doing this until it produces the English that's right most of the time. So we can keep training this. But what we can then do is we can then just switch it over and start giving it Gaelic text instead. And it takes a little bit of a while for it to understand that the switch over has happened. But what's interesting and what's really happened in the last few years is our models have started to become at this level where they actually do better at the Gaelic text because of this change. And the jargon term for this, by the way, is transfer learning. But this is something that's very powerful. And we've done a lot of experiments with this. And in fact, one thing that's been found is that even if you take a completely unrelated language like Japanese and you first train with Japanese and then you were to switch to Gaelic, you would actually still do slightly better at Gaelic, but certainly not anything like as much if you'd first started in Irish. So the similarity of the language helps, but even some training on a large text, even if it's not very related language, will help in terms of this kind of transfer learning. So this is a way that we can go about improving our performance. But of course, we actually want to exploit this more, and we want to try to use some kind of linguistic rules here. So we know things, and as a student of German, if you come across a sentence like "Das ist süß," for those of you who don't speak German, it's probably not very clear what this means. But we actually have these kind of rules that German speakers or German learners or learners of English from German would quickly realize that there's been these kind of changes that have happened. So, for example, the palatal fricatives "the" have changed to "d" sounds in German, and final T's have softened to S's in German, and the U sound was lost in English and changed to E. So if we actually apply these changes, we can get that to an English sentence fairly easily. So we, just as a result of looking at those changes from our German text into our English text. So this is the core of my laureate grant. The Cardamom project is really trying to combine those last two ideas, so our transfer learning and our cognate detection, and trying to bring them together so that we can do tasks like machine translation and other tasks much better by combining those. And this is something we got quite a big grant from the IRC, obviously, to go and look into. So in this project, a particular focus has actually been South Asian languages, so the languages of India and neighboring countries. And there's a few reasons why South Asian languages are interesting. So obviously, India is a massively growing market, so there's a commercial aspect. India is also very linguistically diverse, so it's interesting from a linguistic point of view. And of course, many of the students in our institute are from India and from neighboring countries. But there are some significant challenges in working with South Asian languages. So first of all, they mostly use their own scripts, so unique scripts, which can make lots of challenges in terms of dealing with this. Code switching is something where you use a foreign language within a text, and this is very, very common among South Asian languages. Obviously, English is widely used, and if you've ever seen a Bollywood movie, you know they break into English all the time. But also code switching with other languages within India, particularly from less resource, or from some of the more minority languages in India. And finally, there's a big issue of prestige. Obviously English is, the popular language. All the young people want to speak English. It's kind of the thing. But also when we look at a lot of Indian languages, a lot of them are seen as sort of dialects or variants, and they're not really considered as proper languages. And this is a big challenge. So we have an ongoing project at the moment with a charity called Translators Without Borders. This is through the Adapt Centre. And this is with these people who are Rohingya refugees. So Rohingya refugees are from Myanmar in Burma, and due to political persecution have mostly been forced out of Myanmar at the moment, and are in places, particularly in this place in green, in southeast Bangladesh. So the Rohingya have their own language, which is part of and by many considered just a dialect of Bengali. And also this map here shows the linguistic area. And in fact, this green area is also an area of another language called Chittagonian, which is again considered by many to be just a dialect of Bengali, but isn't really mutually intelligible. It should really, linguists consider it certainly to be a separate language. So we started working with this company or this charity to build translations of terms related to healthcare, related to COVID as well, in these two languages, in Rohingya and Chittagonian. So we obviously we looked at that corpus, how many million words do we have of Rohingya and Chittagonian? Well, the answer was not very many at all. For Rohingya, we had very little, and in fact, it was nearly all written by foreign aid agencies. And for Chittagonian, we actually found nothing initially. Like literally, we could not find any reliable source of Chittagonian text. So that made it very hard for us to understand anything about these languages. But what we started doing, we started looking at social media as a source. So we actually found ways to find keywords that we know are Chittagonian and not standard Bengali. And we started searching through them in YouTube and Facebook. And we found, what is actually the first real kind of corpus of Chittagonian, the first real collection of texts. It's only 3,000 sentences. It's quite short, but for a language which, currently basically has no digital presence at all, we're really starting to try to see, try to collect that and try to have something that's useful for linguists. So this has been enabled by breakthroughs we've made in language identification. So this is a task of, trying to distinguish between two languages. And again, it's a nice supervised task. You give it a bit of text, you say this is either English or French, and you keep training it until it knows this. So language identification is considered by many to be a solved task, in the sense that, that for distinguishing between, say, like a page of English and a page of French, this is something that an undergraduate computer scientist could easily do. But we started looking at harder cases. So here we have results that were presented actually at a conference on Tuesday. And we looked at two data sets. So the first data set is Swiss German. So Swiss German, as you're aware, is a dialect of German that is really quite mutually unintelligible with standard German. In fact, it's common practice for German television to subtitle speakers of Swiss German. But actually, this data set was even harder because it wasn't about distinguishing Swiss German from standard German. We actually had written text from speakers of different cities in Switzerland, writing in their dialect and writing it, phonetically, as there is no standard written form for Swiss German. So they're writing phonetically, and we're actually trying to tell basically which city that person comes from. So it's a bit like telling from kind of phonetic writing whether someone comes from Cork or Galway. It's a very hard data set. The other data set we looked at was the South African languages. So there are 11 South African languages, 9 of which are very close, nearly mutually intelligible Bantu languages. So our system got state-of-the-art performance on this, on Swiss German, outperforming a lot of other very recent benchmarks. And for the slightly easier South African task, we got nearly perfect performance. For Swiss Germans, it's a bit harder, but it's probably fairly close to human performance. But we also looked at this from an unsupervised approach. So in this case, we didn't actually tell the computer which text was in which language. We just asked it to guess which ones seem similar. So this was a much harder task, but is actually what we would need for something like Chittagonian, because as I said, we started off with literally no text. So, we would hope that we could collect some text, maybe use some kind of geographical way of finding tweets or social media posts that are from the area of that, which we know will then be a mixture of standard Bengali and Chittagonian. And actually getting the computer to understand itself which one is which. So this is something which works the results are much poorer, but we're still doing, pretty spectacularly. We're getting up to, 40%. So, a really good kind of, result in terms of how we can identify languages without even our computer having to do anything. So not having to do any manual work. And this is something that's sort of driving our attempts to, to try and build corpora for, these severely unresourced and, low prestige languages. Another thing we've dealt with a lot is code switching. So we have an example here of some Tamil text where an English word has just appeared in appears in text. It's grammatically there. It's valid in the context. It acts as the verb in this sentence, but it's obviously a foreign word. So we're also looking into how we can handle code switching, how we can mark it in the translation process. And we found ways to do this, which can actually really significantly improve translation accuracy. So for systems like Tamil, Dravidian languages, Tamil is an example of a Dravidian language, we can improve our performance from 50-50 to up to 70%. So by handling something like code switching, we really do improve our translation quality. So the other thing I'm going to talk about is historical languages. So historical languages, obviously are under-resourced in the sense that the corpora aren't that big. So we're particularly interested, of course, in Old Irish, and the corpus of Old Irish, it's not very big. It's a few 100,000 words, and it's never getting any bigger, right? There aren't Old Irish speakers who we can go and talk to and ask for more data, because that form of the language is not spoken anymore. So, a lot of the similar techniques we can also apply not just for minority languages, but also for historical languages. And, from a data point of view, we group them together as under-resourced languages, languages where we just don't have enough data yet. So as I say, we started working with Old Irish, and, one of the key ideas, one of the key assumptions that we always make when working with language is a word. So we try to figure out what is a word. So in the slide title here, you'll see I've written this without any spaces. And Old Irish was actually, at the time when spacing was first being introduced, and this was actually basically an invention of the Irish monks at the time. So before that, Latin and Greek had always been written without any spaces between words, much like this title. But of course, this meant that the spacing that appears is inconsistent. So we try to get a spacing between words that matches our modern notion. And we looked, and we had trouble figuring out exactly what this might be in Old Irish. So we got, my student got together some other Old Irish students, and they started looking at what they thought were the words in an Old Irish text. So basically we took an Old Irish text, we got rid of any spaces that had been introduced, and we asked them to just find the word boundaries. And they did not particularly well. They were, disagreeing more than they were agreeing. So we submitted this work, and the first comment we got back was, well, these are students, right? Maybe they just don't have the proficiency in Old Irish to do it properly. So what we did, well, we asked some professors, and the professors were actually marginally worse than the students, or disagreed more, shall we say. So, we were like, well, okay, maybe this is just a hard task. Maybe this is something harder. So we tried it on modern Irish, and we had some speakers who use Irish on a daily basis, and they had no problem. They were 95-98% accuracy. Probably the level of mistakes is more to do with carelessness at this kind of level than necessarily any misunderstanding. We even asked, well, people don't use Old Irish on a modern basis. People don't use Old Irish on a daily basis. So we asked some speakers who had done a leaving cert in Irish and then never used Irish again. People who had not used Irish for a decade, we gave them the same task, an Irish text. without the space, with all the spaces removed, and asked them to put the spaces back in. And they were, you know, obviously not as good at it as the daily users, but they were still able to do it. So this is one of the problems that we discovered, and we're still trying to solve a bit, is really the sort of the definition of a word is quite difficult, and this sort of, you know, is a challenge. And one of the reasons is one of the big things we do is we create these kind of what are called distributional models. So these distributional models are really, you know, based off this quote from a 50s linguist called Firth, and he says, you know the words by a company it keeps. So this means that we can understand what words mean by which words occur in similar nearby in the same sentence, for example. And what we do actually is we translate these into big lists of numbers, into vectors, and then we can plot these on, you know, an X, a Y, and a Z axis like we have here. And we can actually do this in such a way that semantic relationships fall out in the sense that words tend to appear relative to each other in about the same way. So here, for example, we might have masculine and feminine words, and there might be roughly the same path from a word here. So, for example, for man, as there is from king to queen. So man to woman is king to queen. And similarly, we get this for grammatical categories like plural, and even categories where there's, you know, mixtures of grammatical relationships. So here this is language and country. So France to French, or English, or England to English, where there's obviously no relationship in Irish between the surface form of those two words. So we've been interested in this as to how we can kind of measure semantic similarity and semantic change over time. So this is work produced from a Stanford paper, which talks about the changing of meanings of words over time. And the idea is that if we look at words at different points, like words like broadcast or gay, that have changed meaning, we can actually model this, and we can expect to see those vectors move over time. And this is something that we've been looking into, looking at semantic change, and we've been looking at some of our early Irish texts and trying to find the words that are similar. We mostly get kind of, you know, related forms, particularly grammatical variants. But, you know, we also will start to see a little bit of kind of development, and, you know, we hope this is a way to show a little bit about how language changes. So my student who did this has this wonderful kind of visualization of looking at the words that are closely related to this Old Irish word aspert. And we can see a little bit of how these words relate, what words are close, what words are further away. And we can kind of zoom in and start to look at this, and it gives us this really cool way to visualize language change, and, you know, how these words are developed across the temporal corpus. So, next slide. Okay. So the real goal of this work is to create a time machine. It's a bit of almost a joke thing, but, you know, we're actually kind of serious about this. So we have this idea of a linguistic time machine, that we can create models that can take text, and we can understand our models at different points, and we can, you know, we can just roll it back, you know. So we could go and say a modern text, and then we could have, say, an early modern, like a Shakespearean version of that text, or we could even go into Old English, so sort of, you know, contemporary with like Beowulf. And even we hope that, you know, if we can learn about these models, learn about semantic change, we can even predict where they might have come from, and we can even look at prehistoric forms, so forms that, you know, predate any written sources that we have. And this is something that we're looking to, and we're trying to, you know, get this idea of building, you know, models that can change over time, and we can really see how language evolves, and how things have changed semantically and syntactically. Okay, so I'd like to thank you for your time, and thank my people who funded this research, and mostly thank my students and my unit, the Unit for Linguistic Data, who have really done all of this work, of course, you know. So thank you. Time for some questions.
Thank you, John. That was fascinating, I must say, very interesting. And I see that we already have some questions. So the way we're going to do this is you can write your questions in the question and answer, or if you would like to ask a question live, you can raise your hand so that we can give you permission to come live on stream. So the first question we have, John, is from Susanna Pace. And she says that as a Gaelic speaker, she's very interested in the idea of using Irish to teach an AI Gaelic. But she has a question about this. She was recently told that a lot of the differences between Irish and Gaelic are semantic in nature, rather than things that would be picked up by a dictionary, possibly hence a lack of Gaelic dictionary. Do you think that using machine translations from an AI that has learned one from the other might have more problems with distinguishing meaningful semantic differences? And if so, is this only a minor trade-off compared to the potential benefits of having otherwise more accurate machine translations into or out of Gaelic?
Yeah, so that's a really good question. And I mean, she's right, actually. This is something that we do sometimes see in our data, that, you know, when words have shifted meaning slightly between these two languages, you know, the system might, you know, take the version that it's seen more of, which is, you know, from, in this case, the larger Irish as the more well-resourced language. You know, so, you know, obviously we evaluate these translation qualities, you know, both automatically and with speakers, and, you know, it is worth that risk, you know, the extra benefits that we get in terms of, you know, having better performance in the grammar and in many of the core aspects of the language, you know, do make that risk. But yeah, there is certainly that aspect of transfer learning, that you might learn mistakes. And, you know, I think this is also something that you would expect to see of an Irish speaker learning Gaelic, that they'd likely make mistakes that would be typical of Irish, or make mistakes with things that are typical of Irish but aren't used in Gaelic, for example.
Thank you. There's also, well, there are some questions coming in from Facebook as well, but there is one here from Simon Smith. Segmentation is more straightforward for Latin or Japanese than for, say, Chinese, because of the inflection or morphology. Is there less inflection in Old Irish than in Modern Irish?
No, there is in fact far more inflection, far more morphology in Old Irish than Modern Irish.
Okay.
Old Irish has a very complex verbal system that it's one of this issue with word tokenization is particularly challenging for Old Irish because of the rich morphology, and you know, without there being conventions as to whether you know, so I mean, you see this in Modern Irish with things like lenition and prefixing of T's and N's, and in Modern Irish it's pretty much there's been an agreement about whether which belongs to which word, whereas in Old Irish, of course, this isn't, and this is, you know, one of the reasons why there was so much disagreement among our annotators, that they wouldn't.
Considerable disagreement, actually. It was interesting, that slide. Yes.
Yeah.
There's a question from Facebook. How do prose and poetic sources differ in terms of their suitability for this work?
That's a good question. So, I mean, you know, generally we don't do much with poetic work, and it is much harder. It is much more complex in a language. But, you know, when we're looking at historical linguistics, often, you know, poetry is the larger amount of the text. So I guess, you know, the answer to that question really depends on which question you're trying to answer. You know, if you're trying to do machine translation, then poetry is probably not a good target for machine translation, because it's going to be figurative, and it's going to have, you know, a lot of non-literal and a lot more reordering of the words. It's going to make it harder for machine translation. But, you know, there are large-scale projects. There was an ERC funded project in Spain called POS Data, about using kind of AI and linked data approaches to poetry. So some people are looking into this. So.
And in a way, following from this, Susanna Barcani is asking, she's wondering whether these methods can be used to document or save endangered languages, especially with limited written data.
Mm-hmm. Yeah, and this is particularly something like in the Chittagonian example that we see that, I mean, Chittagonian is possibly not hugely under threat, but, you know, it has this aspect that people are more and more, moving towards the standard language, standard Bengali, because, it's seen as less educated to write in dialect. But, it's important to document this, and, these, even, while some might think it's dialect, there are, interesting things about these languages that they need to be documented and represent that, that particular culture. So, we do hope that, preservation, particularly for languages which aren't being preserved because they don't have the prestige and they don't have the support that even we enjoy among minority language, for minority languages in Europe, this is something where certainly we can help.
That was particularly interesting in the code switching reference that you made. I was wondering, does that work when the code switching is not into English?
Yeah, so I mean, it can do. So this particular approach I was looking for was using the script as a key to detect the code switching. So in this case, it was between Tamil and English. So obviously the difference between script made it very easy to find the code switching. But we are also looking into improving our language identification, particularly going down to the word level, so we can detect code switching within the sentence, and then then the same should apply. That by properly marking the code switching, we get improvements, often quite big improvements in performance.
Yeah, interesting. We have some more actually. Quinton Beck is asking, I was very interested in your team's work in distinguishing Swiss German variants, South African languages and Indian languages. I worked on a project in 2018 at the University of Maryland, where the goal was to train AI with OCR ability to read texts in less represented languages as a precursor to computer translation of those texts. So so I'm wondering whether your networks only work with texts that have been manually typed, or if they are able to recognize characters or words directly from images.
Yeah, so I mean, we are dealing with, let's say written text in the sense of digitally represented written texts. So not with the OCR. But of course, it's something we have looked into, and I'm aware that it's a big pain point, that, that OCR doesn't work as well for minority languages because of the way these systems are trained, and they might not be aware of the particular accents that maybe a word has, and they don't work as well. So it's something that's interesting. But yeah, the systems we had, is already been digitized. So.
Thank you. And another one from Cahill Pilo. Does the transfer benefit apply for chains of languages? For example, would a model trained on Irish, then Scottish Gaelic, then Welsh do much better for Breton?
Yeah, so there is some evidence certainly that the more languages you train on, the better as well. So not so much being chained, but just having more languages can help the performance. Now, I think most results tend to sort of, plateau after about 4 or 5 languages, but that certainly happens. But we do also notice that the closeness of a language is a big predictor as well. So I said, even if, Japanese might help a little bit, but much, much less than would have help with Irish. So, if you, it's hard to say on that, but it would be an interesting one to run. I'm not quite sure what would come out.
Thank you. And just wondering if there are any other questions, or anybody wants to ask questions live.
Could I ask a question, Laura?
Yep, go ahead, John.
Hello, John. Thank you very much. I just wanted to ask you, do you distinguish between multilinguality and multilingualism in the title of your talk? I'm just wondering if, I know this is not
making that distinction.
Sorry?
No, I'm not making that distinction.
Oh, okay. No, I was just wondering if there was some reason for it. It's the same very broad concept, so that's fine. Thanks very much.
Just looking at. And John, again from Quinton Beck, what is the best way for us to follow your research?
The best way to follow my research? That's a good question. So I'm active on Twitter. I have a personal website, and yeah, I mean, otherwise we also, of course, through the centers, through Insight and Adapt, of my research comes out that way. And yeah, I guess. But certainly I am on Twitter. It's just at John McCrae, so you can kind of follow my research that way.
Okay. Are there any other questions? I must say I loved your lesson plan robot.
It would make it much easier for robot.
Yes.
We can see whether your lesson is good or not.
Can I ask you actually? See if there's somebody else. Okay, again, this might be a naive question, but since the corpora for some of the modern languages you work on are such a bottleneck, have you considered native speakers on the ground to create translations? Irish minimum wage would be probably considerable.
Yeah, I mean, that's certainly, and it is something that we do and we have done. I mean, it's expensive. You know, if you remember the size of the corpus, we're talking about tens of millions, hundreds of millions of words. Just the man hours to write out 80 million words is you know, just humongous, and you know, it's often not within our resources. So we rely a bit on trying to be smarter and find resources that are already there.
And Stasha, David, could you let Stasha come online so that she can ask a question?
Am I unmuted?
Yes. No, we can hear you.
Okay. I mean, there are two things. One, when you showed that little bird kind of story, that is very interesting and relates to some data that we have. We had some pictures and asked children who were monolingual English speakers and living in English-speaking areas in Ireland, and then were immersed into Gael school, all Irish school. And we looked at children or compared junior infants, senior infants, and first class. And what we see in junior infants, you have English sentence structure and only pop here and there Irish word as they know it. In senior infants, there is kind of lots of Irish words, but slowly moving to the sentence structure of Irish. And then first class is completely Irish sentence structure and only few English words here and there. So it would make sense to maybe look at that, how you structured the story and how you move from syntactic structure of English towards Irish. So there are comparison findings. And the other thing is that there is, and Natalia might be listening to this talk, Natalia Gagarina, who is the leader of that project, there is, it's called the main narrative, and it is constructed to be assessment for of language for multilingual children. And so we have parallel versions produced by the same person describing the same pictures in many different languages. So for example, we are currently collecting data for English and Irish, and we have the same stimulus where people produce stories, or actually we have 4 parallel pictures. So, but the structures are very similar, and it would make sense to maybe look at that and compare.
Yeah, no, that sounds like kind of the answer to the question that we've kind of, you know, got stuck on a bit, that, you know, we're not really sure, you know, how much to apply to target language word order and how much to translate. And, you know, it's hopefully something, you know, very interesting. If you have some citations or something, it'd be great if you could send them on to me.
Sure, yeah.
We have some more questions from Facebook as well. Do you use Bayesian machine learning in your analysis?
Nothing I presented today is particularly Bayesian. We have mostly moved over to deep learning paradigms. Now, you know, I've been, you know, 15 years doing computer science, you know, but we've certainly done lots of Bayesian work recently. We do tend to find that these deep learning models perform better than straight Bayesian models, but there are some wonderful things about Bayesian models. They're very very easy to explain what's going on, unlike a deep learning model. So there are certain times when we still use Bayesian models as one of the tools in our kit.
And again, when will the school projects go ahead?
Well, we don't know. I mean, because it's kind of one of those things. A little bit, it's fallen by the wayside. But we're hoping that we can revitalize this, and maybe when everything's back together and it's more natural for researchers to go into a classroom.
Yes. Would audio information of minority languages compensate the lack of text available?
Audio information, is that?
Discrepancies from the text and speech.
Yeah, so I mean, we're very interested in audio. The reality is that there's just much less audio information available. Text has all of these wonderful things about being relatively small and relatively portable and easy to keep, whereas audio is often much bigger files and much harder to work with. It's much harder for us to process. So we are interested, and we are looking to extend our systems to also take into account audio and visual information that's around a translation. And I have a postdoc who's kind of working on this now. But yeah, in general, there's much less audio data, and it's much harder to get what we need out of it. So we tend not to use it as much.
Understandable. Are there any other questions? Check the various channels here, but no, I think, yeah, I think we're nearly at 7 o'clock, so perfect time, I think. So if there is nothing else, I really would like to thank John for this fascinating talk. Oh, sorry, I think there is something that's just come up now. Yes. Do you have ways of countering cross-linguistic influence from one particular language in a corpus when it is by far the most common, English and Irish?
I'm not quite sure I understand. Do you mean, would we in an Irish text try to detect Anglicisms, for example?
Carol, would you like to ask that question and explain? It's talking about a semantic influence. David, if you could let Carol ask the question.
Well, yeah, that's exactly the kind I meant. Yeah, so like bearlachas in Irish.
Mm-hmm. Yes, that's a good question. So, I mean, certainly, as I said, code switching is something that we're interested in trying to detect and clearly mark the foreign language text. When that foreign language starts to take on the grammatical rules and the target language, that's a bit difficult, and I'm not actually aware of any NLP research into detecting that, but it's something that would be very interesting to see. But yeah, I mean, generally, once something has started to take on the grammar of the target language, we consider that to be the target language from our approaches, because in practice, we need to learn it for that target language, how that works. It's an interesting research area. I definitely think so.
Thank you. Just checking, I think. I don't see other questions coming on. But yes, thank you very much, John. That was really interesting. And we can see that there was a fascinating discussion afterwards, lots of questions. So that was very well received. Thank you very much.
Both for coming. Yeah.
Well, thank you. And I'll just let John announce the next webinar before we close.
Thanks very much again, John McCrae. Fascinating, very interesting overview. And we look forward to having the recorded version as well that we would make available next week. And so just to let everybody know that our next talk is on the 18th of February at this time, so 6 p.m. on Thursday, the 18th of February 2021. And the speaker is Owen de Vardoon from Dublin, who is a traveller language activist, and he'll be speaking to us about the revival of Gammon, or traveller language in Ireland. So that should be very interesting indeed. And we look forward to seeing as many of you as possible back at that on the 18th of February. So thank you very much again for coming. Laura.
Thank you, John, and thank you everybody for coming tonight. I wish to thank particularly the Moore Institute and Director Don Carey for making these webinars possible and for supporting them and supporting CALM. I also would like to thank Martha Shaughnessy for working behind the scene, for making these facilitating these webinars, and of course David Kelly, whose help is absolutely invaluable in putting together the technical side, without which we wouldn't be able to do what we're doing here tonight. So thank you very much, and we hope to see you at our next webinar in February. Thank you. Goodbye.